So on to problem number 16 of the MIT integration book of exam 18, which is the definite integral from x equals to 0 to x equals to pi over 2 of cosine x over 2 minus cosine squared x. I think this is an interesting problem. Let's see how maybe we would solve it. So the problem is from 0 to x equals to pi over 2, integrating cosine of x over 2 minus cosine squared x. So this is the same as from 0 to pi over 2, the derivative of sine x over 2 minus 1 minus cosine squared x is 1 minus sine squared x. Okay, so this becomes from 0 to pi over 2 derivative of sine x over 1 plus sine squared x. So we could say, because sine x really looks very demanding to be substituted, so we would say let u be equal to sine x, and that means that du dx is the same as the derivative of sine x, and therefore du can be used to substitute the derivative of sine x dx. So an important expression there. And then we can see when x is 0, sine of 0 is 0, so u would be equal to 0. X is equals to pi over 2, sine of pi over 2, u would be equal to 1. Okay, so in other words, the integral 0, pi over 2, derivative of sine x over 1 plus sine squared x in the u domain becomes integral from 0 to 1 of 1 over 1 plus u squared. Now this is a very famous integral. We could use u equals to tan theta and go on and do the integration, but to save the misery, this is the same as arctangent of u from 0 to 1, which is the same as limit as u tends to 1, arctangent of u minus limit as u tends to 0, arctangent of u. So here this expression goes to pi over 4, this goes to 0. So the answer now becomes pi over 4 minus 0, which is pi over 4. And therefore, the integral from 0 to pi over 2 of cosine of x over 1 minus cosine, actually 2 minus cosine, let's just delete that and write it well. 2 minus cosine squared of x is the same as pi over 4. And that is our answer.